there are 4 types of transformations, and that we'll study today in the class. So let me write down what are these 4 transformations. First is reflection. Second is translation. Third is rotation. And fourth is enlargement or reduction as well. I'm just giving you a brief introduction of this. The reflection is that how you can reflect an object. Translation, that means you are moving, you're translating. So if you are at one position and then you start moving to other position, you are just translating. So in translation, we have to translate an object. For rotation, as the name suggests, you have to rotate the object. And enlargement reduction, again, you can clearly understand from the word itself, you are enlarging an object. You're just making it bigger or making it smaller. In this lecture, I'm going to talk about reflection specifically. What is reflection? How can you reflect? What is mirror line? And every terms related to it. So let me start. First one is reflection. Reflection, that means you are finding an image of an object. And for that, a mirror is important. Here in mathematics, there is definitely no mirror, no physical object. We are doing it on graph. Let me make x and y axes. This is 1, 2, 3. Suppose the point is here. This position is 4, 3. Clearly, x is 4 and y is 3. Now I have to reflect it about y-axis. Y-axis is my mirror line. Y-axis, that means this one. We know in physics you have studied the distance of the object from the mirror is same as the distance of image from the mirror. That means if something is being reflected, the image is at the same distance as the object is from the mirror. So let me see what is the distance between mirror and the point. So you just have to draw perpendicular, a straight line to the mirror line. This is my point and mirror line is here. So I'll draw a straight perpendicular line. This clearly gives me that we have moved 4 units backwards. We haven't moved in y direction. It's only we moved in x direction. That means we have to move 4 units. If we have moved 4 units, that means the distance between the object and the y-axis is 4 units. That means clearly my image will be 4 units behind the mirror line. Once you reach here, you can clearly see that x is -4 and y is as it is 3. So the reflection of 4, 3 about y-axis is -4, 3. From here, you can easily understand that why during the questions of reflection, the important is a mirror line. So they will definitely mention the mirror line and then you have to reflect about that mirror line. Similarly, let me do a next question. Suppose we have the same point 4, 3, but now you have to reflect it about x-axis. About x-axis, that means about this axis. This is my x-axis. So as I told you, you have to draw perpendicular from the point that you have to reflect to the mirror line. This is the point that you have to reflect and now my mirror line has changed. Previously, my mirror line was y-axis, that's why it goes like this. Now it's x-axis, so perpendicular to x-axis will be this. If you see the distance between them, it's 3 units. And that you have moved in y direction. So the image will be 3 units behind the mirror. So you have to extend, you have to move in the same direction, only the 3 units backward. So this will be 4 remain as it is. -3. Why? Because we have moved in y direction, so x remains same and y changes. Now let me see when other equations are given. Now the point is the same 4, 3, but you have to reflect it about y equals 2. So this is another equation of line given y equals 2. So y equals 2. Many times student really gets confused at y equals 2, then they go for that box method. See, that box method you have to do when x and y both are given. When only y is equals to a number, x is equals to a number is given, it's very simple. You don't need that whole stuff. You can clearly see it says y equals to. Y equals to line suggests that y is exactly the same. X coordinate will change. That's the meaning. Y equals 2. That means doesn't matter what point I'm selecting, my y will be 2. X keeps on changing. And since x keeps on changing, that's why a y equals 2 is being mentioned here. That means I have to find some coordinates. Say for example, a point 1 and comma 2. Now the next point is 6 comma 2. Next is 8 comma 2. I'm changing my x but my y stays the same. That means it's clearly a straight line parallel to x-axis and passing through y2 because everywhere y is same. So this is a straight line parallel to x-axis and passing through y. This is now my mirror line. Same thing I have to do. I'll draw a straight line perpendicular to my mirror line. How many units have I moved? I have moved 1 unit and that too in y direction. 1 unit, that means I need to move forward or you can say behind the mirror line 1 unit. That will give me this point which is 4, 1. So this is my new point. So when 4, 3 is reflected about y equals 2 line, the reflection will be 4, 1. Now we have to reflect the same point 4, 3 at about x equals -1. So x equals -1, that means I'm talking about that straight line where all the value of x remains same. That means doesn't matter which point I'm selecting, the value of x should be -1. That means y keeps on changing. So if y keeps on changing and x remains as it is, that means it can be -1, 2. It can be -1, 5. It can be -1, -5, which means clearly it's a straight line parallel to y-axis, but it's passing through x equals -1. So a straight line that will pass through x equals -1 will be this line. You can clearly see it's a straight line parallel to y-axis and passing through x equals -1. Now the same thing, I have to draw perpendicular from the point to the mirror line. How many units is this? Clearly this is 4 till here and then it's 5 units. That means from here I have to move 5 units backwards, tracing the same path. From here, if I go 5 units backwards, it will be here. That means your new point is definitely -6, comma, and 3 remains as it is. So there is a change in x-axis, there is a change in x coordinates, but the y remains exactly the same. This is how you can reflect it. So far we have seen the mirror lines when we have to reflect it about x-axis, y-axis, when the equation is in terms of only x-axis or only in terms of y. only in terms of x coordinates or just y. Now the equation will be having both x and y, and let me see how we can reflect it. Equation given as y is equals to 3x plus 1. If the equation is given like that, the first thing is, as I told you, that when you have both the variables in your equation, you have to go for box method, which is the most convenient and the simplest one. You can plot any graph using this method. Here, x is independent variable. Always we treat x as independent variable. Independency, that means it has no dependency on any other variable. So if x is independent, that means I can select any value of x. It's on me. I can choose 100, I can choose 50. It's totally on me. The best is you can take these five numbers: -2, -1, 0, 1, 2. In case of a straight line, these fives are the best number. Doesn't matter what equation you are plotting, what straight line equation you are plotting specifically. Always take these 5 points and it will give you a straight line. Even 3 points will work. Now, since x is independent variable, I can choose any values. I have chosen these values. Next is y. Y is dependent variable. If y is dependent variable, that means it has dependency on something. So y has a dependency on x. So since you have selected the value of x, now you have to put the values of x in the given equation to get the value of y. This is our given equation. I have to put the values of x one by one to get the value of y. Y is equals to 3x plus 1. That means I need to put x here, which is -2 in first case. So 3, and replacing x with -2, -6 plus 1 will give you -5. Next is same 3x minus 1, 3x plus 1. You have to replace x with -1. So this will be -3 plus 1 is -2. When you put 0, it will give you 1. The same thing is, you just keep on replacing x and get the value of y. Then this will be 4 and this will be 7. Now I need to plot these coordinates. -2, -5. When x is -2, y is -5. So my first point is here. When x is -1, y is -2. When x is -1, y is -2. Here. When x is 0, y is 1. Here. When x is 1, y is 4. It's here. And when x is 2, y is 7. It's here. Now join these points all together. You'll get the straight line. It would look like this. It's not exact because obviously I have drawn the axes, so the distance between the 2 points can differ, but this is the complete mirror line that you'll find. Now we have to reflect this. As I told you, you have to draw a perpendicular line from the point to the mirror line. This is going to be a perpendicular. Don't draw like this. It's not a perpendicular. Perpendicular is this. Now, you just need a ruler and measure this. That's the best thing. If suppose this is 2 centimeters, 3 centimeters, whatever be the value, you have to trace same backwards in the same direction.
This point will give you the final answer. So ultimately, doesn't matter whatever be the mirror line, you always have to draw a perpendicular line from the point, and whatever be the distance between the point and the mirror line, you have to trace it back in the same direction with the same length. Wherever it ends, the point is going to be the reflected point. So that's it for today in reflection. In the next class, we'll be doing the other transformation. If you need one-on-one live online classes, just email us at exactacademy@gmail.com and we'll reply. Thanks. Have a great day.